Hello, chemistry students. Today is April 15th, 2020. I have to constantly look over here to see what the date is. This will be day 13 of your AMI. Today I'm going to talk to you about the speed of a wave and how to calculate the speed of the wave. There is an equation, of course, to tell us how fast a wave is traveling. And to do that, you use this equation. Velocity, and it's underlined because it's supposed to be in italics, but yeah, we can't do that. We can't write in italics, so we underline it. V for velocity or speed. It's not velocity, it's speed actually. The speed of a wave is equal to lambda times nu. So we're going to take lambda, which is the wavelength of the wave, and multiply it times the frequency of the wave. Now I know we're saying, hey, nu and that V with the underline, they look similar. Well, this is speed. This right here is frequency. And if we take the wavelength of the wave, how long one wave is, times the frequency, you should be able to determine the speed of the wave. Now, you could use this if the wave is traveling through water, through glass, through diamond, through plastic, through air. But there's also another number that we use when it comes to waves, and specifically light waves, but more on that in a second. So that's how we're going to do it. We're going to multiply the wavelength times the frequency to determine the speed of the wave. Now, if light is actually traveling through a vacuum, though, and a vacuum is a place where there is no matter whatsoever. It's devoid of matter. Devoid means that there's nothing. It's missing. It's empty. A vacuum is a space where there is no matter whatsoever. No gases, no elements. It's just emptiness, pure emptiness. Well, in a vacuum, because there's nothing there to interfere with light traveling through it, light travels at its fastest speed possible. This is the fastest that anything can travel actually in this universe, and that is 2.997 times 10 to the 8th meters per second. And we actually represent that. We give the speed of light in a vacuum a very special symbol to represent the speed of light, and that is C. Small letter C represents the speed of light in a vacuum. 2.997 times 10 to the 8th meters per second. It's a very special number because that represents the fastest that anything could possibly travel in this universe. So to take that out of scientific notation, I have 2.997 times 10 to the 8th meters per second. Well, I would have to take that decimal and move it 8 times. So I would wind up with 2997 with 5 zeros attached to it. Then you put little commas there. That means light in a vacuum with nothing to slow it down is going to move 299,700,000 meters in 1 second. Now, according to physics, it's impossible for anything in this universe to ever travel faster than light in a vacuum. Anything that's traveling faster than light in a vacuum is breaking the laws of known physics. But any type of light that is in a vacuum can travel at that speed, which is just a tremendous speed. So to calculate speed, once again, V underlined, that's speed, is equal to the wavelength times the frequency. And that's V equals lambda nu. All right, that is it for today's assignment. That is it for today's notes. There will be an assignment at the end. Make sure you turn that in. It'll all be on one Google Doc again, and you'll turn that in at the end of the week when everyone's done. All right, until then, talk to you later.